In this lesson, we'll review some important things about Servlet and JSP that the rest of the course will rely on. But first, these are the things that we won't spend time reviewing, but still expect you to know. Java, of course, and in particular, how to use collection classes like lists, sets, and maps. And then HTML and CSS, and in particular, how to create tables and forms. And finally, database access, both directly and through JDBC. Now, with that out of the way, let's brush up on our knowledge about web development. Everybody knows how to browse the web. You enter a URL, and the browser goes out somewhere to the web and retrieve a page. So how does that work? Behind the scene, we know that what happens is that based on the URL, the browser will send a request to a server for the page. And again, based on the URL, the server locates a page on the server storage and send it back to the browser. And then the browser displays the page to the user. The protocol used by the client or the browser and the server to exchange messages is the Hypertext Transport Protocol, or HTTP. So the server is usually called an HTTP server. The problem with this is that for certain applications, the server cannot pre-create the pages. For example, Amazon cannot pre-create a shopping cart page until a user selects a product. And Google cannot pre-create a search result page until a user sends a search query. In other words, some pages must be generated on the fly, and that's what we call dynamic content. Conceptually, delivering dynamic content is actually not that hard. As we can see in this picture, it's actually quite similar to delivering static content. The main difference is that we use a program to replace the pre-created pages. And the program, of course, is capable of producing different output. This program is what we call a web application, and consequently, the server is now an application server instead of just an HTTP server, because this server must be able to run web applications. The key thing in this picture I'd like you to remember is that the input of a web application are HTTP requests, and the output are HTTP responses. Web application development, to a large extent, is about understanding what you can get out of HTTP requests and what you need to put into HTTP responses. Because this is a review, we won't go over everything one by one. What we'll do is to use several examples, and each example will highlight some important points in writing Java web applications. We'll start with a simple example that uses a servlet to add two integers together and display the sum. The integers will be sent to the servlet as request parameters. In this example, we'll review these topics: how to create a web project in Eclipse, how to create a servlet, and how to use the web servlet annotation, how to process request parameters, and how to send request parameters using HTML forms, and then how to deploy a project to the CS3 server, which you will need to do for your first homework assignment. Now, let's start by creating a web project. So I have my Eclipse here, and then we can do new project, and then select the dynamic web project. Here, to create the project, we must provide a project name, which I'll call it review. And then, as you can see, we need to select our so-called target runtime. This is where our project will be run, or in other words, the the application server that will run the project, and it says Tomcat version 7. Now here are the list of Tomcat versions and then the corresponding Java JDK versions that it requires. As you can see, to run Tomcat 8, you'll need at least Java 1.7. To run Tomcat 7, you need at least Java 1.6. And also, for each Tomcat version, there's a corresponding servlet and JSP specification version. In other words, Tomcat 8 would support servlet specification 3.1 and the JSP specification 2.3. And for Tomcat 7, it supports only servlet specification 3.0 and the JSP version 2.2. Now, all these numbers are actually not all that important. Just know that the differences between those specifications and those Tomcat server versions are relatively minor from application developers' perspective. In other words, your application developed for Tomcat 6, 7, or 8 should be more or less the same. With that being said, there are some minor differences. So if you develop your web application on one version and you deploy it to a different version, then you need to test it carefully. The version in the web.xml file, which we'll see in a moment, determines the version, the servlet specification version used by your web application, and certain versions must be run on certain Tomcat servers, otherwise it won't work. But let's get back to this when after we created the project and see what the web.xml file looks like. Okay, so we are going to use Tomcat 7, and it corresponds to Servlet 3.0 specification, which is why it shows 3.0 here. Clicks next, and then next. Here there's an option that says generate web.xml file, and by default it's unchecked because in Servlet 3.0 or above, this file is no longer required, but it is recommended that you have this file, and it's particularly useful when you deploy your project to the CS3 server, because the Tomcat server on CS3 monitors the timestamp of this file. When the timestamp of this file is updated, it will reload your project. So if you don't have this file when you deploy your project onto CS3, sometimes after you updated your code, the server doesn't seem to reload your project. So do check this option and create a web.xml file, even though you almost never need to update this file directly. Okay, so we have created our project, and this is the web.xml file, and if you scroll, let's add it a little bit to make it easier to see. So this is the version 3.0 in web.xml file that I mentioned here, and the 3.0, as you can see, require that your Tomcat version to be 7 or above. If you have a web application that says 3.0 and you try to deploy it to a Tomcat 6 server, then it won't work. Okay, so this is about the versions and creating a project, and let's take a look at the directory structure of a Java web application. So this is what's defined in the servlet specification regarding what a Java web application should look like. It should have an application root directory where all the files related to the project or the applications are located, and you can put JSPs and static resources like HTML pages and images directly under this application root directory or any subdirectories under it. And among the subdirectories, there's a special subdirectory called webinf, and this is where you put your Java class files, additional Java libraries, your web.xml file, and so on. And this special directory or special folder is hidden from the client in the sense that the client cannot access anything under this directly by entering the specific URL. And this, as we'll see later, is also where we want to put our JSP files if those JSP files are used in an MVC architecture. So by hiding those JSP files under webinf, we hide them from direct access by the clients, so that the clients, in order to access them, must go through the controllers. Now, if we look at the directory structure of an Eclipse dynamic web project, which we can see if we go to workspace and then go to the project folder of workspace, and that would be review here. So if we go to review, we can see that it doesn't exactly look like the standard directory structure of a Java web application. That's because Eclipse has its own folder structure for Eclipse projects, and only when Eclipse deploy the project to an application server, it converts it to the actual deployment directory structure. But roughly speaking, the web content folder under Eclipse project corresponds to the application root directory, and underneath you can find the special folder webinf, lib, and so on. And another difference is that the standard classes folder is no longer under webinf in Eclipse. It's under a different folder called build, and under build is classes. So if we go up a couple of levels, you can see the build folder, and then the classes folder is here. Now, knowing this is important when you try to deploy your project to CS3, so you need to know where your files are and where those files should be uploaded onto the server. Now, let's create a servlet that does what we're supposed to do, which is to take two parameters and add them together. So let's right click and then select new servlet, and the servlet should be under a package. Exactly what the package name is doesn't really matter, so I'll call it CS520 servlet for the package name, and then the class name is simply add, and I'll leave everything to default. And this is what the servlet looks like. Okay. Let me remove the comments so it's easier to read. So the first thing we notice is this web servlet annotation. And this web servlet annotation is quite important. It replaces lots of functions that used to be in web.xml file. If you look at the documentation of this annotation, you can see that you can use a number of elements for this annotation for various purposes, and important ones are value and URL patterns, and those two are used to map requests to this particular servlet. And here, for example, we are adding any request to this URL/add to this servlet, and equivalent element you can use that is equivalent to value is URL patterns. And another pretty useful element is lowdown startup. By default, servlet is only initialized when a request is sent to that particular servlet. And for certain servlets, as we'll see in our guestbook example later on, those servlets needs to be started before other servlets. And so using lowdown startup, we can initialize and start certain servlets even though there are no requests sent to those servlets yet. So this one is also quite useful. Here are a few examples of using web servlets, and notice that the URL pattern is actually an array, which means that you can map multiple URL patterns to the same servlet. So here is only hello servlet, but here it maps two URL patterns, hello servlet and then /member/star. The second one is also a pattern that has a wildcard in it. In other words, infinite number of URLs can be handled by the same servlet. When you use wildcard patterns, be careful that not all wildcard patterns are valid in Java specification. So the specification says that there are essentially only two types of wildcard patterns that are valid. The first type is a string that begins with a slash and ends with a /star, like /star or /content/star, or in our case, in our example here, /member/star. The second one is a string start with a star dot, like star.html, star.do, and so on. So in the second pattern, as you can see, you can map all the requests that end with a certain suffix to one single servlet. And when you specify multiple elements for the web servlet annotation, instead of using the value element, you typically should use the URL pattern element, which is equivalent to the value element. So when we have specified two elements here, then URL pattern is used. Similarly in here. Okay, so this is about mapping requests to servlets, and we are mapping requests to /add to the servlet. And then we need to handle the request. In particular, we need to handle two request parameters and then display their sum. So how can we do that? Well, it's pretty straightforward. And let's say the two request parameters are a and b. So we can say integer a, and we do an integer parse int, and then do request get parameter a. This will give us the integer value of the first parameter, and similarly we do this for the second parameter, and then we print out the sum. And the way we do that is we can say response dot get writer dot print. Actually, let's print out HTML content instead of just text. So we'll do this. Print writer out is response get writer. And we'll do out print HTML, and we'll do head, title is add, close head, open body, and then inside body we'll say the sum of AE HTML page. Okay, so this should do it. There are few things in this code, although it's pretty simple. There are few things we want to point out. The first thing is how do we get the value of a request parameter? It's simply request.getParameter, and then the name of that parameter. Note that pretty much everything in HTML protocol is text, so parameter, when we do get parameter, is always getting the parameter as a string value, and in order to treat it as an integer, we must convert it into an integer, and then after that we can add them together. The second thing is about generating the output, or in other words, the HTTP response, and here we are essentially printing out HTML by hand by concatenating a bunch of strings and generate the HTML page that has the output. So if we run this code, we'll run it on the server. And it shows a 404. So whenever you see a 404, the first thing you look is the address bar. Notice that the address bar, when you run a project, by default, it shows the root path of the project. But our servlet is not at the root path, it's at /add. So it should be here. And now, however, if we go to that URL, we'll see an exception that says number format exception null, and as you would expect, that's simply because we didn't specify any parameter. So here, integer parseInt is trying to convert a null value into an integer, and that's the reason why we get exception here. If we want, we can add additional code here that checks for null parameters and so on. I'm not going to do that. Instead, I'm going to simply add a couple of parameters. So now it says the sum of 20 and 20 is 40. That's exactly what we entered here. Overall, as you can see, the example is pretty simple, but it shows some basics about creating a servlet, generating response, and so on. And one more thing I want to emphasize is HTTP request. As I said earlier, HTTP requests are essentially input for our web applications. Therefore, they are very, very important. Here is an example of what a typical HTTP request looks like. As we know, an HTTP request consists of a request line, some headers, and then optionally a message body. In this example, we have the request line here, the headers are here, and there's no message body in this request. That part is optional. Now, inside the request line, there's the request method, get, and then there's the path, and this is the part where the server used to locate either a web application like a servlet or a pre-created page on disk. And then the third part is the protocol, which is typically HTTP 1.1 these days. Speaking of request methods, most of the time we deal with get and post methods, but know that there are also other methods that are defined in the HTTP protocol for various purposes. Although most of the time our input comes from request parameters, and that's why we are only showing how to do that in this review example, but keep in mind that sometimes you may also need to look inside the headers to find additional information, and there are corresponding methods in HTTP servlet request class that will help you to retrieve certain headers, get their values, and so on and so forth. So one more thing I want to do before we deploy this project onto CS3 is to create a HTML form that submit data to this servlet. As we can see here, if you want to provide parameters to a servlet or web application, you can simply provide them directly on the URL, on the address line, or as part of the URL. This is referred to as a query string. We can certainly do that, but most of the time you probably would want to use a form. You cannot, for example, expect all your users to be able to manually enter stuff in address bar. So let's create a form, and we'll create an HTML file, which I'll call add form. And in this, I'll create a form. Action is something, method is something, and then we'll say A is a text field with name A, and B is also a text field with the name B, and we want a submit button, which is our type submit, and we close the form. Okay, so if we go to that page, which should be add_form.html, we can see that the two input tags created two input fields, and then there's a submit button, which is called add. For action, that should be the URL to whatever servlet program that's going to process the input. And there are various ways to specify an action. For example, you can do HTTP localhost 8080 review at, and this is referred to as an absolute URL, and you should, generally speaking, avoid using this type of URL, because as soon as you deploy your project to a different server, this URL is no longer valid. For example, when you deploy your project to CS3, this URL becomes CS3, so you have to manually change all your code before you do the development, and obviously that's bad. And there's another type of URL, and this is a relative URL, and when relative URL start with a slash, it's relative to the host root. And you should, again, generally speaking, avoid using this type of URL, because notice that what we are going to submit to is not relative to the host root, it's actually relative to the project root. So in other words, if you want to use this type of URL, then you have to include your project name in the URL as well. Again, this may incur some incompatibility issue or URL issue when you deploy your project on a certain server under a certain context. So generally speaking, you would want to use this type of relative URL. And this type of relative URL, notice that there's no slash at the beginning. It's relative to the current page. So because current page is add form.html, it's relative to this. So we'll say add, it goes to add this URL, and that's the URL for our servlet. So here we'll use this relative URL. And the method decides whether the request will be sent to the server using either a get method or post method. So let's do a get method first. And if we go to form.html, And if type 11, 12, you can see that it works perfectly fine. 11 plus 12 is 23. Now, if we change this one to post, and let's say we refresh and we do 11, 12 again, notice that there's nothing here, no response from the server. And the reason is that in Servlet, GET requests are processed by doGet, and POST requests are processed by doPost. And our doPost method happens to be empty. So to rectify this is pretty easy. All we need to do is simply calling the doGet request in doPost, and that allows us to handle both GET and POST requests. So wait until the server loads the servlet again, and then let's go back, refresh, and then try again. Now this time it works. Right? And also note that for POST request, notice that the request parameters are not sent on the URL line anymore, and this time the parameters are actually sent as part of the HTTP request message body. In other words, we'll do a POST request, the parameters are encoded somewhere down here in the message body. But in any case, we'll do a request get parameter on the server side. The servlet will be able to get the parameters. Okay, so now we have implemented this simple servlet, and let's see how we can deploy it to the CS3 server. So before class, each of you should have got an email, and that email contains your CS3 account information. And I'm going to use account CS520STO31 to do the demonstration. If I log onto CS3 under this account, and this is what the account looks like. Now, what I need to do is to upload my files to somewhere under this account, and we know that it should be under www, and this is where the so-called application root is, the webinf, and so on and so forth. Now, before I do that, please look at this part of the setting up development environment guide. So the server is the CS3 server is running Tomcat 7 using JDK 1.7, but currently the latest JDK is 1.8, and most of the people in the class are probably using 1.8. In fact, I'm using 1.8 myself. So to deploy your project from your computer to the CS3 server, you have to make some changes to your project so that it can generate class files that can be run by JDK 1.7. So what you do is to right-click on the project and then select Properties, and then select Java Compiler, and it will show this screen. So uncheck Use Default Compliance Settings, and then change 1.8 to 1.7. So the first line basically says that it will generate class files that it can be run by JDK 1.7, and the second line basically says that it will check your source code and make sure that there's no 1.8 specific features in your source code. So change this to 1.7, and then click Apply, and then OK. Now, if you don't do this, after you upload your class files to the CS3 server, you'll see an error message that says wrong major minor version number or something. So if you saw that error message, come back here, set the compatibility level, and then try again. So now that I've done that, and let's upload the files. So my files, as we mentioned earlier, is under review. So under web content, I should upload this file. And then my class files are under build classes, and those class files should go under webinf classes on the server. Notice that there are subfolders under the classes folder, and you should preserve that subfolder structure, because that's how Java packages work. The subfolder structure matches the package name. So drag everything from here to here. And last but not least, upload the web.xml file. And this basically tells the server that I have uploaded a project, or I have updated my project, and please reload it. So now I have everything on the server. Let's go to the right URL to access it. The URL should be cs3.custody.la.edu8080, and then my account name, which is cs520sto31, and then add form.html, and this shows the form. And if I type in a couple of values and then click add, it shows the result. Notice the URL, it goes to the servlet, it runs the servlet, and the servlet displays the result. So this is about the deployment part. And when you do your homework assignments, sometimes you deploy your code to CS3, there's some errors, you update your class files and so on. Whenever you update your class files and re-uploaded them, you would want to either re-upload the web.xml file, or if you use WinSCP, you can perform a touch command. It's if you right-click on the file and select custom commands and touch, and you can run this. So what these touch commands do is it simply updates the timestamp of the file, and when the timestamp of the web.xml file is updated, Tomcat server will reload your project to reflect your changes. So keep this in mind. Lots of problems come from the projects not being reloaded. Okay, so then let's move on to our second example, the guestbook example. So if you have taken my 320 class, you must have already been intimately familiar with the guestbook example. Basically what we'll do is we'll create an old-fashioned guestbook where people can leave messages for a website owner, and typically they will leave their name and then some nice things to say about the website. Click submit, and then the site will display their name and messages. So I'm not going to go into details about creating this example, because again, many of you have already seen this example countless of times. But this is still a very important example, and I would like to use this example to refresh your memory regarding several subjects, including model view controller architecture, scopes of data, expression languages, and GSTL. I have already created the code for this example here, and let's first run it, and then we'll go over the code a little bit. So okay. Right. So this is the main page of the guestbook application. If a user wants to leave a comment, they can click add comment and then give their name and then their message, and it displays the name and message here, and they can add it. So it says cat2, and here it shows the total number of comments that we have so far. So it's pretty simple. Now, looking at an application like that, so how do we go about and creating such an application? I think the first thing I would like to talk about this application is when we are tasked to create a web application, where do we start? I think the single most important thing is to understand that for the vast majority of web applications, there are simply data plus operations. For example, to look at an example like a guestbook, you can say those guestbook entries that contain a visitor's name and a visitor's message are the data of this application. And similarly, if you look at some other applications like online blogging site or web forums, wiki pages, and Twitter, and so on. So they are all applications essentially managing certain data, whether they are blog entries or products on Amazon or pages on Wikipedia or messages on Twitter, and so on. And then in addition to the data, you have operations that you perform on those data. For example, the most common operations are add or create, search, display, edit, delete, and so on. And in our example, it's displaying the guestbook entries, editing entry, adding an entry, and so on. So once you think of a web application like this way, or in other words, once you break down a web application into data and individual operations, it becomes much easier to implement such an application. All you need to do is first create some classes to hold the data, and then for each operation, you implement each operation one by one, instead of trying to do everything at the same time, and the implementation or the development becomes a lot easier. To make it even easier and more organized, we typically use the so-called model view controller architecture, and each operation becomes a path like this. So for example, for a display operation, the browser will send a request to a controller, and the controller will retrieve data to be displayed, and the controller will then pass the data to some page to display the data, and the page renders the response and send back to the browser. So each component in this path has a name, and they are called controller, and the data part is called model, and the part that is responsible for generating the user display or final display is called view, and with Servlet and JSP, typically the model or the data part of the application is implemented using Java beans, or the so-called POJOs, plain old Java objects. The controllers are implemented using servlets, and the views are implemented using JSPs with HTML, CSS, expression language, custom tags like JSDL, and so on and so forth. So having this in mind, let's quickly go over the source code of the guestbook example. Like I said, the data of the application is basically a guestbook entries. So what we do is we create a class that hold those data. And here I have a class called guestbook entry, has two fields, name and comment, and that's enough for this simple application. Notice that there are some constructors and getters and setters, but this class is just a simple Java class. It doesn't rely on any web-related libraries or APIs, and this is why it's also called a POJO, a plain old Java object, which essentially means that it doesn't rely on any web-related API. And the good thing about that is you can reuse these classes in different settings. For example, if you want to build an Android client or a desktop client, and you can no longer use web-related libraries and APIs, but you can always reuse your model classes. So this is the model part, and if we look at the operations of this application, we have three operations. We have the display operation that displays the guestbook. We have the add operation that adds comment, and we have edit operation that edits a particular comment. And similarly, we would have three controllers, or in our case, three servlets, that each implements a single operation. Right? So the guestbook controller or the guestbook servlet is responsible for implementing the display operation. Notice that in the servlet or the controller part, it doesn't display anything directly, and that's because in a model view controller architecture, the controller simply forward any data to be displayed to a view, and that view is a JSP page, and this is where the display actually happens. And for add operation, it does similar things, and similarly for edit. Now, okay, going back to display, let me point out two things which are important. One is scope, and one is the expression languages and custom tag libraries that are used in the JSP page. So first, about the scopes. If you remember, there are four scopes in Java EE: the application scope, the session scope, request scope, and page scope. Data stored in application scope is valid throughout the life cycle of the web application, and in addition to that, all Servlet and JSPs have access to the same application scope data. So the first thing we did in the guestbook servlet is to store a couple of entries, to pre-create a couple of entries and store them in the application scope. To store anything in application scope, we do servlet context set attribute, and servlet context is what's called the application scope. And because the data is in application scope, notice that we didn't need to pass any data to the JSP, because the JSP can access the application scope data directly, which is why inside this JSP, it can simply say entries and then go through each entry and do the display and so on. So there are other scopes. For example, there's also the session scope, and in our next example regarding login logout, we'll use the session scope to store data that are related to a particular user session, and then there's this request scope, which we use to store data that is only used for a particular request. Page scope is used actually quite rarely, so don't worry about page scope. In addition to the scope thing, it's very important that you brush up on your knowledge about expression language and JSTL. So here, as we can see, we access the scoped data using the so-called expression language. In other words, the $, parentheses, and then the variable or attribute name. And also in expression language, you can access the so-called bin properties inside an object. So entry.name will give us the name of entry object. Entry.comment will give us a comment value of entry object. And remember that bin properties, let me see where are the, yeah, remember that bin properties are defined by getters and setters. In other words, if you look at the getBook entry class, the getName, setName, getComment, setComment method define the bin properties name and comment. Remember that they are not defined by fields, they are defined by getters and setters, and they follow certain naming conventions. So in getters and setters, the first letter is capitalized, but in the property name, the first letter is always in lowercase, and so on. So expression language, very, very important. And also important is custom library, in particular the so-called JSTL. This is a tag library that we use most often, particularly the core library that provides lots of useful tags, the flow control tags like if, else, for each, and the URL tags, and so on. So here, for example, we're using a for each tag to iterate through a collection of objects, and then for each object we display something. And also we have an example here that uses the functions sublibrary in the JSTL, and this function sublibrary defines a number of so-called expression language functions, and most of them deal with manipulating strings and characters. And the first one, length, will return the length of a string if you pass a string, or it can also be used on a collection, and it will return the number of elements in a collection, which is what we are doing here. We apply length on entries, and it returns the number of elements in that collection, which is 3. And last but not least, to use JSTL, don't forget to declare the tag library, and each tag library has a unique identifier which you use in the URI attribute, and then you give it a prefix, and then later on you can use that prefix to reference that library and get using tags in that library. We won't spend the time to review everything about expression language and JSTL, but know that those two are very, very important. You are going to use them very often later on. So if you forgot about how to use them, please spend some time reviewing your CS320 materials. Okay, so one more thing about this example. Let me put something here. One more thing about this example I'd like to discuss is the so-called form processing operation. For example, edit comment. Remember that in this example, in this guestbook example, we have three operations. We have the display operation, we have the add operation, and we have the edit operation. Our display operation is pretty straightforward. It just displays something and that's it. But for adding and editing, notice that those operations actually involves two sub-operations. The first one is you have to display a form, right? And then the user fill out something in the form and then click submit button, and then you have to process whatever the user has submitted. So in other words, in a form processing operation, there are usually two sub-operations, form display and form processing. If you look at how we implemented the add comment operation, you can see that what we did was we used doGet to forward the request to a JSP, and that JSP displays a form. And then in that form, notice that it uses the post method, and the post method will submit a request back to this servlet again. And in this servlet, the doPost part will handle the form processing responsibility. So when a user submits something using a post request, it comes to here, and here we retrieve the data, we add, we get the name and message from the user request, and we create a new guestbook entry and add to the list of entries. So in other words, the convention of implementing a form processing operation in Servlet is for form display, we implement it in doGet method, and for form processing, we implement it in doPost methods. In other words, we use one servlet to handle both sub-operations. It is, of course, possible that you split this two into two servlets, and there's nothing wrong about that, except that you have to create one additional servlet. But the convention is to use doGet to do form display, doPost to do form processing, and it makes the code a little bit more compact, and it's just how typically this thing is handled in Servlet. Okay, so now we remember the basics, and let's add a little bit to this with our third example. So let's say that we require a user to log in before they can add or edit comments to the guestbook. In other words, we'll create a login page, and the user would provide a username and password, and if the username and password are correct, we allow them to add comment and edit comment. And in addition to that, we'll add a logout link that lets the user to log out. So in this example, this one should be here. In this example, I want to review two subjects. One is session tracking, and one is a basic login logout mechanism. We know that login logout is usually implemented using a special session attribute. So for operations that you want to protect, you check whether a special session attribute is set. If it's set, you'll know the user has logged in, and then you can proceed. And if it's not, you send the user to a login page. And the function of the login is to check the user's credentials, and if the user's credentials are correct, you set that special session attribute that can be used to check later on whether the user has logged in or not. So having that in mind, let's change our code a little bit. So let's run this. and guest book. Okay, so if we want the users to log in before adding comments, it's good that we hide this link if the user hasn't logged in yet. So let's let's do it in a different way. So right now, if I click on add comment, I can simply add any comment, and but let's say we want to protect that function. So the way to protect that function is, as I mentioned, we want to check for a specific session attribute. So here, instead of simply displaying the form, we'll say what session attribute we want to use. Let's say we want to use the session attribute user. So we'll say string user request get session get attribute user, and okay, so we have to pass it to a string, and we say if user is null, which means that that special session attribute is not set. We'll say response send redirect, and we'll redirect the user to the login page, and then then that's more or less it. And otherwise, it will display the form. So similarly, we would want to do this check in doPost. And if the user is null, we send redirect and we return. And if it's not null, we get to here, we get the entries, and the name is no longer from the parameter. It's going to be whatever value stored in the user attribute. And okay, so this should do it, and let's see. If we go back here, we refresh, we click add comment. So notice that because we have a login, and this time we are automatically redirect to this login URL. I haven't created the login servlet yet, so there's nothing here. So far so good. Now let's create the login function. Remember that the login function is once again a form processing operation, because first we have to show a form, and then the user enters something and submit. We have to check the credentials. So that's the form processing part. So let's say we create that servlet, and that servlet is going to be called login. Actually, let me stop the server first. We create login servlet. Okay, so do get, we perform form display, so we'll do request get request dispatcher. We'll use a page called login.jsp to display the form, and we forward the request and then the response. So in doPost, this is where the user submit the login form, and this is where we check the username and password. So we'll say username is request get parameter username, and then password is request parameter password. Once we have the username and password, we can do username and password checking, and typically you would look up your database or look up your directory service to check the username and password. But since it's a simple example, we simply check if the username and password matches CY_SUN and ABCD. So we say if username equals ignore case to CY_SUN and password equals ABCD, and then we set special session attribute. Don't forget this. This is the whole point of doing the logging thing. And then redirect the user to someplace, and here we'll simply redirect to the main page. To set the special session attribute, it would be get session set attribute. And remember, the special attribute we check for is user. So we'll say user, and then since we only have one user, it must be CY_SUN. And then we say response dot send redirect guestbook. And if it doesn't match, we simply send it back to login again. And then let's create the login page. The login page should be quite simple actually. Let's just copy this add form here. I'm going to rename it to login.jsp, and action is login, method is post, this one is username, this one is password, and the type, I'm going to use text for both so we can see the password, but of course in a real application you would want to use the password type, but here I want to actually see the password. And then here login, and then it says login. So now we have our login operation. Once again, it's a form processing operation. Do get forward to view, and then do post process the data. And why don't we just create the logout as well? So logout is pretty simple. Remember that to log a user out, just do a session invalidate. So we'll do get session invalidate. This will remove all the data associated with the session, and then remove the session, which is the right way to log somebody out. And once the user is logged out, we can send the user back to guestbook again. Okay, so yeah, so let's run this and see what happens. go to guest book and we click add comment. This time it takes us to the login page, and I enter CY-SUM ABCD login. So login is successful. We are at the main page again. If I click add comment again, this shows us the add comment page. I can then, enter something, say hi, and it says CY-SUM says hi. Notice that it doesn't say Tom says hi. It says CY-SUM, and that of course simply because instead of using the request parameter Tom, it's actually getting the name of the user from the session. Okay. So this is how login logout works, and the main thing is A, the basic login logout mechanism, which is essentially using a special session attribute, and B, to create session attribute, we can simply say request get session to retrieve the session, and then add any attribute to that session. Let's make this, let's change it a little bit so that we have the logout link. So let's say I have a logout link. Logout. Okay, so it shows a logout link, and if right now I'm logged in, if I click add comment, it shows a form, and if I log out and I click here, it goes to the login page. This works fine, except that this logout link is always shown here, which doesn't look very good. So how can we change this so that the logout link is only shown after the user has already logged in? Well, that can be done fairly easily. So we basically want to check whether the user has already logged in. So how do we check that? Well, we can say see if test something something, and then we show that logout link. So what is something something? Well, we'll say not entity session scope user. What this means is that it checks whether there's a session scope attribute called user. If we do have that, it will show the logout link. If we don't have that, this will not be shown. So if we refresh, notice that there's no logout link because we are not logged in yet. Now let's log in. The logout link is here now. So this is how we can access session attributes and so on inside JSP. You can say session scope, or in fact we can remove session scope and just check for user. The purpose of session scope is that if you have two attributes, one in session and for example the other one in application scope, if both of them have the same name but in different scope, you can distinguish them by adding the scope in front of the attribute or variable name. But if you only have one variable and there are no variables with the same name, then this one actually can be omitted and it still works like before. Okay, so this is how we can implement login logout. You could, as an exercise, you can also add login logout to the edit function, and I'm not going to do that since the basics are clear. Okay, so the last example, I'd like to do something non-trivial and see how we can put all these things together, knowing what we know about how to implement Java web applications and so on. The example came from the Papa John Pizza's website. So on Papa John Pizza's website, there's a page where the customer can customize their own pizza. So you can, for example, choose from several crusts, and then there are some options like whether you want normal cheese or extra cheese or no cheese, and whether you want regular sauce or barbecue sauce, and then you can pick your toppings and so on. So to make it simpler, we simplified the problem by selecting only 3 types of crust, and then only cheese or no cheese option, and then only 4 types of toppings, and each topping would cost $1 extra. So it's a simplification of this, but it's essentially the same thing. If you want more options or more toppings, it's trivial to add. So let's say this is what we want to do, and we want to then create a page like this where the user can pick the crust from a drop-down list, and then use radio buttons to pick whether they want normal cheese or no cheese, and then use checkboxes to select the toppings. And then we want to display an order page where it shows the order the user had picked, the quantity. We can also let the user to update quantity to say I want 2 of this, 1 of this, and then it should display the prices and the total as well. And if a user wants to add another pizza, it clicks add another pizza and goes back to this page. If the user changes the quantity, they can click update order, and then it will update the quantity and update the prices. And then there's a place order button. If in a real website, when user clicks place order, the website should go to the page where the user entered their credit card information and so on. And for us, we'll skip that step. So if a user clicks place order, we'll basically remove everything and start over. Okay, so as you can see, this example looks quite a bit more complex than our guestbook example, and it is more or less a real-world example that you would expect. And when you look at an application like this, the first question is always, where do we start? Right? So where do we start? Well, remember, what is a web application? As we said earlier, what is a web application? A web application is really data plus operations, right? So when you look at an application like this, the first thing you would want to do is you want to identify the data, and then you identify the operations, and then things become a lot easier from there. So how do we identify data? Well, the trick of identifying data is to look for nonce in your application description or requirement description. So if we look at our example, we can find a bunch of nonce in the problem description. For example, we'll see we have pizza, right? And then we have crust, and we have cheese, we have toppings, we have order, something like that, right? So we look at this and we say, okay, we have pizza, crust, cheese, topping, and order. That seems to be it. So once we have the nouns, then what? Well, the second thing we would want to do is to determine whether a noun should become a class or a field. So what do I mean by that? Because we are using Java, essentially data needs to be represented as classes, and there's no question about that. But if you look at a noun like pizza or a noun like a topping, right? So do you represent this using a class, or do you represent this as a field in a class? That is the question. So how do you decide? Well, the rule of thumb is that if a noun contains more than one value, then it should become a class. And if a noun has only one value, then you can probably represent it as a field. So for example, if we look at a pizza, what is a pizza? Well, a pizza needs to have a crust, and it needs to have cheese, and it needs to have cheese or no cheese, and then it needs to have one or 0 or more toppings, right? And in other words, a pizza contains a number of other things, so pizza itself probably cannot be a field. In other words, it makes sense to create a class called pizza. So in our case, pizza should be a class. If we look at crust, what about crust? Well, for crust, each crust has a name, right? And then it has a base price for that crust, and different crusts have different prices. So in other words, this crust thing has two values, a name and a price. And that again indicates that crust probably should be a class. And what about cheese? Now cheese, you would think that it has two values, normal and no cheese, but it's actually only need one variable to represent, right? In fact, we don't even need to store the actual string. We can simply store this as a Boolean value, Boolean variable, where true representing normal cheese and false representing no cheese, right? So as we can see, it makes sense to represent cheese as a field. What about topping? If you look at topping, you may think that toppings are like crusts. They have a name, and then they have a price. But in our simplified example, each topping has the same price. Right? All toppings have the same price, $1. So in other words, that value doesn't have to be stored with every single topping. So in this particular example, we can actually see that the topping probably doesn't need a separate class either. So topping probably can also be represented as a simple field. And the order, since the order has a number of pizzas and quantities, and the chances are order probably should be a class by itself. And speaking of quantity, actually quantity is also a noun. And what about quantity? Quantity, if you look at this, it seems like property or field in order, but what we are looking at in an order is essentially entries of order entries, and each order entry has a pizza and has a quantity of pizza. So we would also have a class called order entry that has both of these values, something like this. Order entry. Right. Okay. So now we have our data, or in other words, our classes and fields. And what about the operations? If we look at this example, what are the operations we need to create? Well, we will have an operation called customize pizza, right? And then we'll have an operation that displays the order, and we'll have an operation updates the order and then place the order. So we are looking at customize pizza and display order, update order, place order. Now for customize pizza, there's a form display, and then there's a form processing. And for display order, actually if we want, we can combine display order and update order, where display order is the form display part and update order is the form processing part. Actually, yeah, why don't we do that? We'll say it's probably better to put them separately. Conceptually, they look, it makes more sense. Okay, so these are our operations, and these are our data. Now, if we look at this, now relatively complex application become much easier to tackle. So instead of trying to do everything at the same time, now we can first create the data and then later implement these operations one by one. And let's see if we can do that very quickly. Okay, so I'm going to create a new project and called pizza and web.xml. And so I'm going to create a class. How many classes are we going to create? Pizza crust order entry. We'll start with the simplest one, the crust. Let me change this package name to CS520 mod. Okay, so for a crust, we have a name, and we have a price, and let's create a constructor for that. And then okay, so now I have a crust class, and then let's create a pizza class. So what is a pizza? Well, a pizza needs to have a crust, of course. And then what else? Well, a pizza has a crust and then option of cheese or no cheese. So we'll say Boolean cheese. And then a number of toppings. So we'll say toppings. And that's more or less it. Let's generate the getters and setters. And then we want the class of order entry. So an order entry is basically a pizza plus a quantity. Now, strictly speaking, we should probably create this class, but considering that it's really just a pizza and quantity, so I'm going to simplify things a little bit and simply put quantity in the pizza class. Quantity. And then the order class becomes simply a list of pizza Okay, so we now have our data or our models, and then let's implement those operations. So the first operation is customize pizza, and let's create a servlet for that. The package would be controller, and it's called customize pizza. And for this one, I want to get do post and also init, because I want to pre-create some toppings and crusts. So remember, we'll do init, override init. You want to call super class init first, otherwise you'll get into some errors. And here we'll pre-create the list of crusts and the toppings that user can choose from. And so, for example, we'll have a list of crusts. And we'll add a new crust in there. And a new crust is large original, $11, so it's going to be large original, $11. And then we add a couple of more, medium original and large thin. So medium original and large thin. Medium original is $9. Okay. So now I have my crust, and very similarly we'll create the toppings, and this one will be called toppings, and we'll say new array list, and toppings will add, what toppings do we have? Pepperoni, sausage, and bacon, and pineapple. So pepperoni, sausage, bacon, pineapple, sausage, bacon, and pineapple. Okay. So I have my toppings, and then we store both in application scope. And the way to do that is to say get servlet context, set attribute crusts, and then we do toppings and toppings. So now we have a list of crusts and list of toppings. Think of them as your data in databases. Since we are not using databases, we are using application scope to store them. And to make sure this one is started before every other servlet starts, we'll say load on start up is 1. Okay, then here we'll display the customized pizza page, and to do that we don't really need to do much in the servlet itself. Simply do a request forward request get request dispatcher, and customize pizza.jsp, and then forward request and response. Okay, so looking good. And then let's create the page. We'll create a JSP page called customize pizza.jsp, and that page should look like this. We need to have a crust and let the user to select from a list of crusts. Okay, so what we have is going to be a form. The action would be customize pizza servlet itself. The method is going to be post because we use doGet for display, and then we will have crust, and the crust should be a select with name crust. And then we have options. In order to get the options, we are going to iterate through the crust list in application scope. For each crust, we'll say option will be, how do we get the crust? Okay, let's say we have a value being the index of the crust, and crust name, and then crust price, something like this. Okay, so to get the JSTL, we need to do a couple of things. First, we need to import it. Let me grab it from here. And when I set up my environment, I didn't add the JSTL library to the server because later on we'll use Maven to automatically add all the libraries to our project. And because of that, I have to add JSTL jar files manually. What we can do is we can go here and then download this zip file, which is the JSTL tag library. And from that zip file, grab two jar files, JSTL.jar and standard.jar, and then put those two jar files under the lib folder of my project. Remember, that's where we put additional libraries. So copy over to the lib folder. And okay, now we have the JSTL library. Why is giving me an error? Unknown C for each. Okay, let's try this and see if it works. So we'll run the pizza project. Customize pizza. So it says 404 and it says cannot find customize pizza.jsp. And okay, that's because I missed an E there. And it's not showing anything here. Crusts. Let's check if, that's because I called it crust instead of crusts. And let's refresh this. Okay, so now I have my crusts, right? Which is great. Then let's add the cheese part. So we'll say cheese and no cheese. And here we want to use a radio button. So we'll say normal cheese. Value is cheese and no cheese. Input its radio, name is cheese, value is no cheese. How does it look like? Cheese, no cheese, cheese, no cheese, normal cheese, no cheese. Okay, great. And then let's do the toppings. And for toppings, we want checkboxes. So we'll say C for each items is toppings, and var is topping, and we'll have an input which is checkbox, which name is topping, value is topping, and the topping, and new line, and then what? There's a button that says add to order, so that should be a submit button. Name is add, value is add to order. Okay, so let's see what it looks like. Okay, not too bad. And let's do a view source and make sure, yeah, everything looks okay. Okay, so now we have the page where the user can customize a pizza, and then let's do the add to order thing. Right now, add to order doesn't do anything because do post is not yet implemented. Okay, so here we do add to order, and the first thing we do is, of course, get the order. So where do we get the order? Well, naturally, it should come from session. So we'll say order is request get session get attribute order. Right. Now, notice here that class and toppings are stored in application scope because they are shared by all the users and they never change. However, each individual user has a different order, so you should not store order in application scope. Then everybody end up with the same order. It should be in session scope, which is specific to a particular user. Now, right now we actually haven't created any order in session yet. So when this line of code is called for the first time, it actually returns a null. So we'll have to check for that. We'll say if order is null, then we create a new order, okay? And then we set that order into session scope. And after this, we will have an order no matter what. And then we set the crust to the order. And the way we do that is we have to get the crust from the list of crust in the application scope. So let's say we get the list of crust from get servlet context get attribute crust. Okay. And we need to get which crust the user has selected, and that can be done by getting the parameter of crust, which is the index of the crust the user selects. As you can see, the option value 0 and 1 and 2. So here we'll say integer crust index is integer dot pass int request get parameter crust. So before we add the crust, we have to create a new pizza first. So pizza is new pizza. Right. And then pizza dot set crust would be crusts get crust index. Okay, so now we have the crust, and then we set the cheese, no cheese option. So we'll say if request get parameter cheese is not null, this means the user have checked this radio button, and in that case we'll say pizza dot set cheese to true, otherwise we do pizza set cheese to false. And then we get all the toppings, and here we need to do something like this. We'll say request get parameter values. So notice that so far we've been doing get parameter and then parameter name, and however, in HTTP protocol, it's possible that we have multiple parameters having the same name, and just like in this case, user can check multiple toppings, and all of the parameters will have the same parameter name topping. So in order to handle that, we need to use a different method called get parameter values. This one will retrieve all the values of multiple parameters that have the same name, and it returns them as a string. So we'll say something like for topping request get parameter values topping, and then pizza dot get toppings dot add topping. So this would add all the toppings to the pizza, and then once we're done with everything, we send the user to the display order page, and that will be response dot send redirect display order, something like this. Okay. So before we do anything else, let's quickly recap what we have done. We have created all the class and toppings, and then store them in application scope, and then on this page, we have displayed all the customization options using drop-down list, radio buttons, and then checkboxes. And then in the do post part, we have created a pizza and created the order if it doesn't exist yet, and then we have processed all the parameters, and based on the parameters populate all the fields in the pizza. So let me see how much time we have if we have more time we can proceed, otherwise. Okay, so yeah, let's it's not even 2 hours yet, so let's at least do the display order part. And with that part, it also makes sure that our customization, our customized pizza operation actually works. Okay, so let me do the display servlet display order, and okay, so display order will be do get and do post, and in do post we'll simply call do get, and then here we'll do request get request dispatcher, and dispatch to display order JSP, and then forward request and response. Okay, great. And notice that here we don't really need to retrieve any data, because the data is either in the application scope or session scope, and in both cases they can be accessed directly in the JSP. Okay, so let's create the JSP. It's going to be called display order, and what display order should look like. Display order should show pizza, quantity, price, and then total price, and some buttons or links. Okay, so we'll do a table, and the table will have a row that says pizza, quantity, what am I doing? It should be TR, and then TH, pizza, quantity, and then price, and then we'll do for each and list all the pizza. In order to do for each, we'll have to get the JSTL. So where do we get all the pizza? It should be in order, and it's a list of pizza in order. Okay, so it should be order dot pizzas and pizza, and for each pizza we display a row. The first one is pizza dot. The first one shows the crust and cheese and bacon. Okay, we'll say something like this. We'll say pizza crust dot name, comma, and then if test pizza dot cheese, we'll say no more cheese. And if test not pizza cheese, we'll say no cheese. And then we'll need to use for each to display all the toppings. Pizza.toppings. Something like that. Okay, so all of this is in the first cell, and then the second cell is a quantity, which we also put into pizza, and then the third one is price. Let's leave that out for now. And then after that, we'll say the total is something. Again, we'll leave the total price out for now. Okay, so let's see how this thing works. Let me start the server. We refresh. We have this one. So let's say I choose medium original and no cheese, and then pepperoni and sausage, and click add order. So I get a null pointer exception. Obviously, this happens quite a bit. Let's see what went wrong. It's line 86. Let me go to line 86, which is here. It says pizza get toppings add null pointer. Okay, so that is probably because I didn't initialize topping, so I don't have a topping list, but I'm trying to add to it. That obviously is not good. So what we do is we say toppings is new array list of strings. So this will create an empty list of toppings that we can add to later on, and that should solve the problem. And let's go back and try again. Refresh. Medium, no cheese, pepperoni and sausage, add to order. Okay, so seems like a customized pizza works, but there's nothing being displayed here. Now, usually what we do here is we do a first view source, make sure that the tags are okay, and then we go back to display order. So we didn't do much here, must be in JSP, and here we say order.pizzas, and in customize pizza. Oh, okay. So here we created an order, we created a new pizza, but we didn't add the pizza to the order. That's why when we say order pizzas, we didn't get anything. So well, to avoid the same problem as before, let me first create a empty list of pizzas. And then let's actually add that pizza to the order. Add pizza to order. So I'll say order get pizzas add pizza, and then we do the redirect. Okay, so this time it should work, I hope. Go back, refresh, medium, no cheese, pepperoni and sausage, add to order. Okay, so now we have medium. Why it says normal cheese? It should it checks cheese and displays normal cheese. But I thought I let me see. Oh, that's because we are sending the request parameter cheese, and the parameter itself is not null, no matter what. We have to check the value. Okay, so here we have to change this one. So instead of just checking whether it's null or not, we'll have to say get parameter equals to cheese, right? And then it's true, otherwise it's not, right? Okay. And wait for it to restart. Refresh. Medium. This one, let's make it a large original, no cheese, bacon and pineapple. Large, no cheese, bacon and pineapple. Notice that because the server has restarted, all the session data was gone. That's why we are only having one pizza here. If we go back and try again, this gives us a second pizza. Okay, so far so good. And then let's talk about the price thing. So price is actually a special value. So remember when we talk about data, we say the nonce are pizza, crust, cheese topping, order, quantity, and so on. And we missed one thing, and that's price. Price is also a non, right? But price, if you think about it, is neither a class nor a field. Well, it's obviously not a class because it only has one value, but it's also not a field in the sense that price is not an inherent attribute of a pizza. It's actually determined by which crust you choose, whether you want cheese or not, how many toppings you choose, right? So there's a third type of data, so to speak, and what we call the derived values. And price is actually a derived value. And for a derived value, we don't need to actually store it. And in fact, it's bad if you store a derived value, because then if anything changes, it could lead to inconsistency in your data. So for derived value, what we do is we create a property without creating a field. What I mean by that is we'll do something like this. We'll say get price. So remember that bin properties are defined by getters and setters. So when I create a getter called getPrice, we are adding a new property to the bin without adding a new field. And the price is the price of the crust, right? And if no cheese, we subtract $1 from price, and then we add $1 for each topping to the price, and that's the size of the topping list, and this is the price of our pizza. Okay? And similarly, the price of the order is simply the total price of the pizza. So we'll say for public double get price, and price starts with 0, and then for each pizza in the order, price is simply the sum of the pizza's price. Okay. And so once we have those, then we can display them here. So for the pizza's price, it's simply pizza.price, and the total price is simply order.price. So let's run this and see if it works. Go to customize pizza, and we'll start with a medium, no cheese, and one topping. So no cheese and one topping, it should give us $9, right? So this pizza's price is $9, and the total is $9. If we go back and add a large original with cheese and 3 toppings, and this one should give us 11 plus 3, $14. So 14, and then the total price is 23. Okay, I'm going to stop here for this example, just to quickly recap. When we look at the application, web application, think of it as data plus operations, and for data, you pick your nouns, decide for each one whether it should be a class or a field or derived value, and then create your model classes accordingly. And then for operations, you simply go by them one by one, and even complex web applications can become fairly simple. Well, not fairly simple, but let's say relatively simple. To summarize, a Java web application consists of many components: servlets, JSP, static resources like images, style sheets, and HTML pages, and metadata files like web.xml. The model view controller architecture is very, very important. It puts all these things together. And once you break a web application down to data and operations, even complex applications can be implemented in a relatively straightforward way. Okay, that's the end of this lesson.